Working really closely with a lot of different research departments and companies on accelerating deep learning. Of course, deep learning is a part of machine learning. It's really starting to take off. It's being used in everything from image recognition to voice synthesis. One of the areas that we've done a lot of development in is in medical imaging, for example, being able to recognize cancer cells and doing things in machine learning and deep learning to help radiologists. That same kind of approach, though, can be applied for automotive applications. And so for object recognition, for pedestrian detection, for lane keeping, all these kinds of systems, we can actually use deep learning, building a deep neural network, accelerating it with GPUs to make it real time now, and have it run in the vehicle. So really now deep learning and the creation of a deep neural network that runs in the car is fundamental to our autonomous car development. One of the demonstrations that we're showing here actually illustrates kind of how the brain of the self-driving car works. Okay. And so the process is actually training the neural network, and this may happen offline. So we'll feed it hours and hours of video, maybe 10,000 hours, 20,000 hours, maybe 100,000 hours of video. And the system then learns how to recognize different types of objects. And the key thing here and what we're illustrating is now the ability to not just see, oh, there's a car, but is it an ambulance versus a truck? Is it a police car versus a taxi cab? And recognize that if the emergency lights are on, our autonomous car will need to know that and be able to pull over. And this goes on into many different areas, being able to recognize pedestrians, and a pedestrian that is distracted maybe, somebody who's looking at their cell phone, and be able to recognize that a ball is out in the street and to then anticipate what's going to happen next. Very likely a child coming into the road, even though it doesn't initially see the child. Or being able to recognize a parked car with a door slightly ajar, what's going to happen next is the door will open. So these are all things, it's the images, but the behavior that we need to adjust according to those images that will be fundamental. So again, a two-step process where we train the neural net